Hello guys, welcome back to the channel. So in today's video, we're going to continue with our series on working with agentic RAG systems. In this video particularly, we're going to be looking at how to work with tool calling, or basically function calling. So if you have been on the channel for a while now, we have covered videos on basically whole series on agents, right? Agentic AI systems working with LLMs, right? So in this video, we're going to be going ahead and basically learn how to use function calling that we also learned in the previous videos on working with agentic AI systems using LLMs. You're going to learn how to basically perform what we call function calling within an agentic RAG system. So basically, agents have these basically Python functions, and then they use these functions as tools to do different things, to perform different actions. So basically, an agentic RAG basically uses a tool to perform RAG retrieval and augmented generation. That's what basically it does. So it, at the end of the day, these are just tools that is using and calling these tools to perform different actions. So let's take a look at the things that we'll be looking at in this video. So in this video, we're going to cover all about tool calling in working within an agentic RAG system. We're going to be looking at the recap of the previous tutorial. What are tools? What is function calling? Why do we need tool calling or function calling? How to set up and everything. And then we'll go over examples of functions that we can use. We'll create our own tools using Python functions, learn how to turn these tools into turn these functions into tools. We'll then go ahead and do different testing, and also lastly we'll do a vector search with metadata, so we can perform vector search. Example, let's say you have a PDF document on 10 pages and you want to search information only from maybe page 7, so you can do that using metadata search, vector search. So good. So let's jump into it. So in the last video, we looked at working with query router query engines, right? So in this video, this is what we did in the last video. For those guys who missed the last video, you can always go back and watch the last video. Again, you can find a link to that on the main channels page, or I can even drop a link in the video description. Or you can click a card up here. If I remember, I'll keep a card up here, so you guys can click on that card and access the new video. The previous video, which is a router query engine video. So basically, we discuss is how a router query engine works. We have a document. We break the document down into smaller pieces, smaller sections called chunks or nodes in Llama-Index, and then create vectors, the vector store index and the summary store index, and then we use those to create vector query engines. And then these query engines will be used by the router query engine to select which of the tools to use in order to answer the question. So you can think of the query engines as basically tools, right? Because it's an agentic RAG system. Good. So what is a tool and why do we need a tool? So let's take a look at what is a tool. So let me just go back right here. So what is a tool? A tool basically is a function, Python function that we pass to an LLMs, or basically LLMs, that the LLM can call to interact with the external world. Let's say that you have a tool. You basically want a tool. You have data on, let's say you have an e-commerce application that you're trying to build a RAG system on, so that users can ask different questions about products and services and other stuff like that, right? So maybe in this e-commerce application that you're building, there is already an API that the front end consumes. So you can basically write a Python function to interact with this API in order to pull different product information. So you can pull things like you can pass in the product name and returns you the product information like the price, the quantity in stock, the discounts available, and all that information, right? So you can build basically a tool, or basically a Python function that you can call to be able to perform this function, right? So good. So these are basically just tools. So once you give this function that is going to be able to call your e-commerce API, once you give it to an LLM, it becomes a tool to the LLM that the LLM can use to call that API, get information of different products, and then use that detailed information product to answer the user question. So let's say the user asks about product, ask information about product on headphones, right? So basically, you just search the API, the e-commerce API on headphones. Once you get the headphone information, or maybe you have multiple headphones that you're selling, or that's stored in a database, so you get all this headphone information and you just return this information back to the LLM, and based on the information, the LLM can now answer the user question. So that's basically a tool. That's a Python function. Okay, good. So why do we need tool calling or function calling? I'm going to be using this word interchangeably because I want you to get used to it. So tool calling is the same as function calling, right? Because a tool is just a Python function anyway. So why do we need tool calling? So you might be like you might be like me, initially thinking, why do we need to call tools? I mean, the LLM course role is in a RAG system is to synthesize information, right? To generate information. Why do we need it now to introduce our own custom tool to it? So the reason being is that if you read the last article, which the last basically, if you watch the last video, how we determine the best route, basically using the router query engine to execute. When working with the router query engine, the LLM uses a selector, right? Selector selects basing on this query that I have, which tool do I use? Like basing on the query that the user query, it determines whether to use the summary query engine or the vector query engine, right? So imagine building a booking system with an LLM, or want to write the output of a RAG pipeline into a file automatically. So let's take the context of trying to have a booking system. So once a user is chatting with the bot, right, you don't have control over what's really going on. You can't really, because like you are not in charge of that conversation. It's the LLM and the user. So you're trying to build a booking system. So the user wants to book a room, right? And you want to take the booking information and store it in a database so that you are like, let's say you're trying to book a hotel, right? So that you want to store that booking information inside of the hotel's database so that everybody is aware that room X, Y, and Z has already been booked or has already been occupied. So how do you do that, or how do you achieve that, right? Using a RAG system, web, or basically a chatbot. So one of the ways you can do this is having a function. So you basically provide a function to the LLM that the LLM can call, and passing some parameters that can be used to write some information into a database or a file or anything like that, right? So the user wants to, hey, okay, this is a user talking to a chatbot, right? I want to book room X, Y, and Z for 2 nights. So basically that information has been provided to the LLM. The LLM should see, okay, now I need to call a function that is going to register this booking information instead of a database, right? So with regular RAG, you can't really achieve that, but with tool calling, you can achieve that. So that's one of the reasons why we need tool calling, to be able to interact with the external world. The LLM to be able to interact with the external world, such as external databases, external files, anything, right? So you can think of it from different perspectives. So anything that enables the LLM to interact with the external world, you need a tool. That's why we need tool calling or function calling. So I hope that example clears things up. Okay, so I've already looked at why we really need tool calling. So now let's go ahead and really set up and initialize our notebook. So I'm going to go ahead and use the the environment setup that you had from the last video. Okay, so all I'm going to go ahead and do is just create a new file under here. I'm going to go ahead and create a new file, and this is file, I'm going to call it basically lesson underscore 02.ipynb. Okay, good. So once that's done, basically we are going to be using this to learn how to perform tool calling. Okay, so the couple of things we need to do. So let's go ahead and select the right environment. So select the Python environment and make sure you select this one right here. His environment is, so just select that one right there. Okay, so once I have it, I'm going to go ahead and simply add it, basically let's say tool, okay, tool calling. Okay, so I have typos right there. Tool calling or function calling, let's say with Agentic RAG systems. Good. So once we have that done, let me just close the side panel because we don't need it for now. Oh, okay, I need to pull a couple of things from here. So I'm just going to go to the previous notes, and I'm going to go ahead and simply copy this right here, copy that, and I'm going to go ahead and simply paste it here just to bring in those environment variables and load in everything that you need. So in regards of the environment variable. So good. So that's all we need to do. So I've explained all this in the last video, so I'm not going to go ahead and explain them in this video again. So good. So once we have that, now we need to go ahead. Let's see what we've already done the setup already. So now let's go ahead and look at some sample functions. So basically, again, tool calling is just Python functions that are being called by an LLM. That's basically it, right? So let's take a look at how we can implement that. So basically, let me just add a comment right here. So what this is going to be sample. You're going to have some sample functions just to explain things to you from a fundamental point of view. So functions for tools. Good. So now I'm going to go in here. So we're going to go ahead and define a couple of Python functions. So let's say def, and this is going to be add, and we're going to say x. It's going to be of type integer, and we're going to pass in y. You have it's going to be of type integer, and once we add these two, we're going to go ahead and return an integer. Like an integer plus an integer is going to be an integer. So let's go ahead and add in some doc strings right here. So add two numbers together. basically it, and then return that. So that's basically what we have. So we have subtract as well, and then subtract. Good. So we can have that. We also can have the multiply. Perfect. Multiply the two numbers. Good. So once we have those right there, so you can also go write a division function and all that you want. So I'm going to go ahead and say get underscore user underscore info. So this is a function. We can basically think of it like a function that returns to you a user information, right? So good. So now basically we're just going to go ahead and get rid of that. So I'm going to pass in, let's say, data, and this is going to be, you can also call it database. You can think of it as database. So database, just like that. And in here, you're going to have a couple of things, right? You can have basically a username, and it's going to be, let's call this one John Doe. So John Doe. Good. We can have an age. We can have an email address. Perfect. So good. So that's basically one of the users that we have. So again, let me just go ahead and reformat this. So email is going to be John Doe at example. Okay, let me get example.com. Okay, that's basically my email right there. So what I want to do, I'm just gonna go ahead and simply copy all this. So I'm gonna copy all this, and then finally I'm going to say John, and I'm going to go ahead and pass in now a dictionary which we have just created. So passing that dictionary there. So good. That's basically what I want to have right here. Okay, so I think I made a mistake on that. So, and then paste it here properly, and then make sure I have that saved, well formatted. So I'm just going to go ahead and tab this in to make it well formatted. I'm going to go ahead and copy this information, put a comma right here, and then replace it to be Jane. So Jane, and this is going to be Jane Doe. Okay, and it's going to be, let's say Jane is 25. Okay, let's say Jane is 20 or 23, anything you want. Okay, let's say Jane is 20, and this is going to be Jane at gmail.com. And then basically you're going to expect passing the username. So when you say username, and it's going to be of type str. Good. So once the username is passed in, okay, you're basically going to go ahead and return the user's information. So you're going to say, I want to use an s string right here, username, and you're going to go ahead and simply say the username. So it's going to be the data that you're going to get from the database, right? So it's going to be the username. So I'm going to go to username, and then the user information. You can pass in all this information as much as you want. So that's basically it. So information, we're getting the username. You can get a variety of things that you want from the database. So in this case, I'm just going to keep it this simple. So you can think of this function as basically something that connects, you're getting an information from your database. Basically, you can think of it like an API that you're calling with this function. So basically, we're going to pass it into the LLM, and the LLM can use it to call different functions to get different data back, right? So that's basically how it's going to work. So let's go ahead and learn how we can use this inside of a tool, create a bunch of tools, and passing these functions as the tools to, or basically the functions to these tools that they can call, right? So let's go ahead and do that. So to do this, I'm simply going to go ahead and scroll down here. I'm going to go ahead and add in a markdown here so that you document like everything you're doing. So basically creating tools from Python functions. That's basically it. So that's basically what you're doing. You're trying to create a tool from Python functions, right? So that's what you're trying to do right here. So creating tools from Python functions, or basically turning Python functions into tools that LLMs can use, right? Good. So what we need to do, I'm going to say from Llama-Index.core.tools, I'm going to go ahead and import function tool, just like that. Okay, function tool. Okay, that's basically it. I'm also going to say I'm going to go ahead and create the tools for, you can create a tool for all these functions if you want to, but let's just keep it. Let's say addition underscore tool is going to be equals to a function tool, and then you're going to go ahead and pass in the addition. Okay, let's say you're going to say tool dot from underscore default, and you're going to go ahead and add in our addition function. That's basically it. Or you can do also pass in the keyword argument function is equals to the addition function which you have, and the addition function is this one right here, right? So good. So we can also go ahead and create other tools for subtraction tool, division tool. So you can say subtraction tool again. Okay, let me just uncomment this line, and this is going to be equals to this, and pass in the subtraction function, which is this one right here. So you can just create all these tools as much as you want. So you can also go ahead and create the multiplication tool, and then go ahead and create the multiplication tool as well. Okay, so multiplication tool, and then create that tool as well. And you can also create the division tool, division tool. Okay, division underscore tool, and this is going to be division tool, and we have the division function right here. Oh, I don't have a division function, so I'm going to go ahead and create the get user information tool. So I'm going to say get user information tool, and this is going to be equals to function tools dot from default, and passing in this function right here, which we have above here. This function right here is what you're calling in right here. So good, that's basically all you need to create tools, right? So we can go ahead and create tools. You're going to go ahead and pass in all these tools into our a flat Python list right here. So good. So once we have all that created, we are good to go. So attribute function has no from default. Okay, so from defaults, okay, my bad. So from defaults, okay, from defaults, and also this is from defaults. So good. So I just call that function, right? Just passing from defaults and then passing all the tools that you have created into a flat Python list. So once we have that tools, what's next? So once we have that tools, we can go ahead and test out these tools and use these tools to perform different things. Good. So let's go ahead, add in a markdown right here just to document everything. So we just say testing, test out the file, the tool calling. Just basically that's it. So basically testing out the ability to call these tools. So I'm going to say from Llama-Index LLMs.OpenAI. I'm going to go ahead and import the OpenAI key, and then we say LLM is going to be equals to going to create an instance of OpenAI, and then we're going to use the model as a GPT 3.5 model. So model equals to, you're going to use basically it's called the GPT hyphen 3.5 turbo, and basically that's it. So I can just go ahead and get rid of this because I'm getting these auto completions from GitHub Copilot. Okay, so good. So once I have passed in the model, I can go ahead and now I get a response, ask a question, and then get a response back. So LLM dot equals to, you're going to say LLM equals to LLM dot predict and underscore call. So basically you calling this function, which is predict and call. So what you're going to pass, you're going to pass in our tools, which is a list of tools, and you're going to pass in basically no, I don't need to pass in this. So I can just go and pass in verbose equals to be true. That's basically it. So we're passing in the tools, which is the tool that we created above here. We're passing in the prompt, basically what question you're asking this LLM, which is basically add 2 and 3. So adding 2 and 3, it should be able to call the addition function, right? So let's go ahead and test it out and see what we get back. So I'm going to go ahead and simply print the string response, the string version of the response. Okay, good. So once we have this done, I'm just going to go ahead and run this, and let's see what we get back. So we're basically asking it, okay, we got an error right here. It says that completion.create got unexpected argument prompt. Okay, so I don't think I need this right here. So let's just leave it. Okay, good. So that's all we need to do. So we're passing in tools, so I can just go ahead and get rid of this as well. So tools, and then the argument that you're passing in, we can also go ahead and read it from here if you want to, and all that. Okay, so I'm just going to go ahead and run that, and let's see what we get back from this. So calling the addition tool with arguments 2 and 3. Good, which is what we ask it to do. So let me go back here. How did it know it needed 2 and 3? So good, that's why we have all this right here. We have this type hints, which tells it which data type this function, this function needs to be passed to. Okay, basically what arguments need to be passed into this function and what type the arguments need to be. So you can see that it needs to pass in x and y, and x and y are basically integers, and this function returns an integer. So add 2 numbers. Basically we need also to provide this docstring. So if you remove this docstring, basically the LLM doesn't know what this function can do. So this docstring basically tells the LLM gives a description of the tool to the LLM, or a description of the function, aka tool, to the LLM, right? So we need to pass in this docstring so the LLM can know which tool to call. Okay, so if you don't pass in this, it wouldn't work. If you don't pass in the type hints, it wouldn't work. So make sure you pass in the type hints and the docstrings as well. So the docstrings are the tool description, and this one does tell it the argument description and the return type description, right? So you need to pass in all those for it to work. Now let's go ahead and try to get information about a given user. So we're going to go ahead and copy all this right here. Copy this, and I'm going to go ahead and paste it right here, and basically say tell me more information about John. Okay, John, and let's see what it does, right? So we are asking to tell us information about John. So you can see it's calling get user tool, and with this argument it's passing the username as John, and it's going to get John info, and it's okay. So we didn't, let's go back in here. I think we have an issue right here in this function call. So we're going to go ahead and simply get the username, and if it doesn't find the username, it's returning this right here. So the reason why we're getting this issue is that it's returning to us an uppercase of J, and but here we're getting the lowercase, right? So we need to go ahead and simply say dot. I think we have a function in Python that say lower. If I'm not mistaken, this function now should now convert this into a lowercase. Okay, I think it's a method of a string. So let's go ahead and try it. Also going to say dot lower. Yeah, perfect. So we call that, run this again, and we need to run everything again. Good. So once we have that, we can go back in here and run this all. So now you should now get the John's information. You can see John name is John Doe, age is 25, username. So you can think of this could be a function that calls an API to get product information of your e-commerce store, right? So you can see you can get all that information and then use that information to reply to the user. So let's go and ask a question. Tell me how let's say how old is John. So tell me how old is John, and let's see what it does. So it gets the John's information, and you can see it got all that information, and you can use this information to answer the user's question, right? Good. So that's basically how tool calling works with agentic RAG systems. So good. So we are good to go right here. So now once we end again, you can format all this information, right? You can go back in here and make sure that you pass all this information in a well formatted format instead of returning just a dictionary. You can clean this up and make it look prettier so that the LLM can easily understand, right? Good. So once you have done that, you have learned the basics of tool calling, and you have also learned, we have also tested it out and how to use them. So now let's look at metadata, how you can use metadata to filter information. So in here, you're going to go ahead and read in a PDF file. Okay, so we're going to use the PDF file from the last video, which is the Laura_ paper, which is just a fine-tuning paper. So you can, it's an awesome paper, right? So you can read about it if you want to. But basically what I want to do is right here, again, let's document everything we are doing. So basically vector search with metadata, just like that. And then we run that. So basically what we want to do right here is to read in our document, right? So we say from Llama-Index.core, we're going to go ahead and import, we're going to import simple directory reader. Good. So once we have that, we're going to go ahead and simply read in Laura paper. Okay, so we're going to go ahead and simply say document is going to be equals to simple directory reader. We're going to simply say and then call this, and you're going to go ahead and pass in input underscore files, and you're going to pass in a list right here, and then pass in that Laura paper, the Laura paper. You're going to simply say load data, and then call the load data method on that. So once you have that, I can run that. So okay, made a mistake right here. So it's in actually a folder called data sets and not data. So that's sometimes the downside of using GitHub out or GitHub Copilots. So let me just see data sets. So data sets and then /LauraPaper.pdf. Okay, so that's one of the disadvantages of using GitHub Copilot. Sometimes the suggestions are quite not the right one. So good. So once we have that document read, and again we did all this in the last video, so I'm going to go over this a bit quickly. If you want to refresher, you can always check back the last video. So once I have this read, I'm going to go ahead and create a splitter and split this into what we call chunks or smaller chunks, or basically nodes as they're called in Llama-Index. So I'm going to say from Llama-Index.core.node parser, I'm going to go ahead and import sentence splitter right there. So I'm going to go ahead and simply say I'm going to create a splitter object. So splitter, and splitter is going to be equals to the following. So splitter is going to be sentence splitter, and you're going to go ahead and pass in the chunk size. So we're going to say okay, chunk size, and you're going to use 1024 for the chunk size. Okay, again, if you don't know all this about chunk size, chunk overlap, we covered all this in my previous RAG vanilla RAGs tutorials or series. You can check those out. Okay, so I'm going to create this going to say setting. No, basically we need to create nodes from this. So I'm going to say nodes is going to be equals to splitter dot get underscore nodes from document, and you're going to pass in our documents that we have, the documents variable, which is going to be documents, which is what we have up here. Okay, good. So once I have that, I'm going to go ahead and run this all, and you're going to get nodes. Let's get the length of how many smaller nodes or smaller chunks we have from splitting. So we say nodes and then run this. So we have 38 different smaller nodes. So this document, which is the LoRa paper, has been split into 38 different smaller sections or documents. So once we have that split and then nodes created, so we're going to go ahead and create embedding model and also the OpenAI model and use those to be able to create a vector index. So we're going to say from Llama-Index.core, I'm going to go .core. I'm going to go ahead and import the settings. I'm going to also going to say from Llama-Index.core, I'm going to go ahead and LLMs. So I'm going to import the LLMs. You're going to go ahead and import OpenAI. Good. And you're going to say from Llama-Index.embeddings.OpenAI, you're going to import the OpenAI embedding. Good. So once you have that, you're going to go ahead and create a model. So I'm going to say settings.llm is going to be equals to the OpenAI and then create the model right there. And embedding, you're going to use the OpenAI embeddings. You're going to specify the model right here. And the model is going to be equals to the following. So you're going to use the model. You're going to use text, basically text embedding, ADA. You're going to use 002. That's okay. So let me just check the name. So text embedding hyphen data hyphen ADA hyphen 002. So that's basically, so run that. Okay, so it says I cannot import. Okay, let's go ahead and see what we need to do. So from okay, let me just go ahead from llms.openai open. So let me just, okay, so it's actually not .core, it's .llms.openai. You're going to go ahead and import that. Okay, and we had that already imported above here, so that was just a typo from my end. Okay, good. So once we have that done, you're going to go ahead and create basically an index. So I'm going to say from Llama-Index.core, I'm going to go ahead and import the following. So I'm going to go ahead and import vector store index. So I'm going to go ahead and say vector underscore index. It's going to be equals to, I'm going to say vector index, and then we're going to go ahead and pass in node, and then we're going to say nodes is going to be the nodes that we have, and the nodes are just the document that have been split into smaller sections. In this case, we have 38 different smaller sections. So go ahead and run this, and that's going to go ahead and create a vector. Okay, vector index. Sorry, my bad. I have to run this one more time. Good. Okay, so I'm using tokens right there. Okay, so don't make such errors. So once we have done this, now we can go ahead, and the last video we learned how to filter information, right? How to basically ask the vector index a question, and then basically get a document that can be used to respond to that question, or has the document that has the information that we can use to respond to the user's question. So in this section, you're going to go ahead and learn how to basically use metadata filters. So let's go ahead and say from Llama-Index.core.vector store, we're going to go ahead and import metadata filter. So we're going to have that right there. So we're going to go ahead and pass in, create a query engine from our vector store. It's going to be equals to the vector query engine. So query underscore engine. Okay, let me just give it a good name. It's going to be equals to the vector dot as query engine, and you're going to go ahead and pass in the similarity. You're going to say, okay, as vector query. So this is going to be as vector query engine. You're going to pass in as the similarity, and the similarity you're going to use it to be the more similarity. Let me say similarity underscore top. And you're going to set that to be a value like 2, 5. Okay, so I'm going to use 2, or let's use 3 in this case. So similarity underscore top underscore k. So I forgot that. So underscore k. Okay, so we're getting the k, the top 3, or the 3 most k, the 3 most similar documents, right? So that's basically it. So we're going to go ahead and pass in filters. Going to pass in filters. I'm going to go ahead and pass in, it's going to be the metadata filter. You're going to go ahead and pass in a couple of metadata. So I'm going to say, okay, this needs sometimes auto suggestion is just really crap. Okay, so get that in there. So sometimes it's just good to type things out yourself. So I'm going to say from underscore defaults from, okay, from, you can use it from dict. That's good. From dicts. Okay, so dictionaries right there. And what you can do is you can go ahead and pass in a couple of things, right? So you can pass in dictionary right here, and you can go ahead and say key, and the key is going to be equals to the page underscore label. And the page label, if you print out the information from these nodes, you can be able to see the page label. Okay, So we have done that in the last video, so I'll just go ahead and skip over that. So you're going to use the page label to filter. You're also going to say the value. In this case, you're going to set the value to be by default. Let's say we're going to be about, let's say, page 7 or page 6. Okay, that's basically it. So you're filtering some information from page 6 of our LoRa paper. That's what you're trying to do right here. Good. So once we have that there, we're just saying it from dictionaries, you pass in all this. That's all we need to do. So once we have this specified in here, we can go ahead and simply just close off this. Okay, close off this function. Okay, so once we have it, I'm going to say response. We're going to go ahead and try to get a response. Is going to be equals to the query engine dot query. Basically ask it basically a question. So we're going to ask it basically what is LoRa, and you're going to go ahead and simply do a print of the response. So print of the string response, the string version of the response. So that's basically it. So that's basically what you're trying to do here. Just say query engine dot query, and you have created a query engine from the vector index that we had earlier on, which is from here, right? So you're using it to create a query engine, using the as query engine method, passing in the similarity top k value, and then passing in the filter that you want to filter by. So that's basically it. So let's ask the question, and let's say tell me, let me just ask the question. Let's change the question right here. So say tell me about the problem, so it's this problem statement of the, okay, let's tell me about the problem statement as explained. So it's going to go ahead and search for information. So metadata from dictionary, we get an error right here. So let's go ahead and see. So meta filter. So meta filter. Okay, meta filters. Okay, my bad right there. So it's meta filters. And then let's try to run this. So yeah, so we can see right here, you got an empty response. So we are basically trying to filter information basically on page 6. So let's change this to be page 2, and page 2 has information. Okay, this needs to be a string right here. So page 2, and this needs to be I'm specifying page 2 because I have read page 2 where they specify the problem statement. So I'm basically asking it a question that is whose a response can be obtained from page 2 of the document. So it's only the response. You can also print the response sources, and you should find that the response source is only from page 2. So I'm going to say let's take all the source that was used to answer the question. We're going to say for n in response dot source nodes underscore nodes source nodes, you're going to go ahead and simply print each of these. So n dot metadata, getting the page, all that information. So let's go ahead and try to do that. So let me just get rid of this. Okay, so get rid of that. So and you're getting the metadata. Let's just do this instead. So what I'm going to simply do is just print the n dot get underscore text information, just to get the text back, and this will be you can end that right here. So that's basically it. So run this. Let me just bring all the way. Okay, this, so you can see right here, this information has been obtained particularly from page 2. So if you go ahead and simply remove this, and let's try to print the whole node information, you can see the whole information has been obtained right here, right? So you can go ahead and print all that information. I think you can also go ahead and print a page label, if I'm not mistaken. So page label. Okay, I don't think it has a page label information right here. But basically, you can go ahead and simply print the get underscore text, and you can see from which particular page you got that information was obtained from, right? Good. And you can also print different information from this node, like the page information and all that other information, so you can see from which particular page a given data was obtained from, right? So basically, you can also go ahead and let's print the metadata. So let's say print n dot metadata, and you can get all that information. So if I scroll up here, you can see this was obtained from exactly page 2, right? And it was obtained, this is just metadata information, so it was obtained from page 2 of the document, and because we set the filter to be page 2, so basically it's only going to filter based on page 2. It's only going to search for the answer from page 2 and not any other page, right? So that's basically how that filter can work. So good. So do we have to always passing this filter information? Let's say tell me about the problem statement as explained in page 2, right? In page 2. So in this case, I want the LM to be able to figure out that this value right here needs to be 2, because I want. So how are we able to achieve that, so that we don't have to actually manually pass this information in? So to do that, we can write a function, and use that function as a tool. So I'm just going to go ahead and paste this function right here. It's a lot of stuff and I don't want you guys watching me type all this out. But basically we can just pass in a list of pages, or I want some information from page 1 to page 2, and it's going to go ahead and return for us those list of information. So basically that's all we need to do. So once we have that's there, and it's going to go ahead and ask the query engine and then return to us the final response. So we can actually call this function and pass in the information that we want. So basically now we need to convert this Python function into a tool that LLMs can use. So to do that, you're going to use, we've already seen how to do this already. I'm just going to go over it one more time. So to do that, I'm going to say a vector underscore query underscore tool is going to be equals to function dot from default, and then function we're going to use the vector query engine tool. And you can also go ahead and give it a name if you want to. So you can go ahead and simply say name, and you can give it a name right here. You're going to say vector underscore search, vector search basically query, or basically anything you want, vector query. I want to call it query underscore tool. That's basically. So let me just break this down onto multiple lines so that you guys can see that clearly. So break that down into multiple lines, and then we'll clean this up. Okay, good. So that's basically it, and I can just go ahead and create that tool. So once we have the vector query tool, we can begin to use this tool by using the LLM predict that you've already seen. So I'm going to say response is going to be equals to LLM.predict call. You're going to go ahead and pass in a couple of things. So we're going to pass in the tools right here. Sorry, the tools that we need, and you're going to use the vector tool. You're going to go ask the question, and then basically you're going to say verbose is true. That's basically it. And then once we have that, I'm going to go up here and copy the question that we already have here. So I'm going to go ahead and copy this question right here, and then move all the way down here and paste in the question that I just copied. So tell me more about sorry. Okay, so I copied the wrong thing. So let me just go up and copy this one more time. Sorry for that. So let me just copy this again. So make sure I hit Control C on that, and then Control C again, just to be sure. Go down here, and then in here, let me just go ahead and hit Control V. Good. So basically, tell me more about, okay, like that, right? So tell me more about the problem statement as explained in page 2. So in this time, you're not specifying any statically defined information. It's going to call the tool, and it's going to go ahead and specify the page number. So you can see it's using page 2 and passing that as page 2. So if I pass in here page 3, it's going to go ahead and give me summary information about that, right? So good. So that's basically how you can use these functions, basically turn Python functions into tools, or turn query vectors, vector indexes into query engine, turn them from query engine to query tools, right? Good. So you can also go ahead and print out the responses right here. So you can print out the response source document. So I can just copy this right here, and we can utilize it right here as well. So just to get a view of which document have been returned, and you can see it's from page 2, right? Good. So that shows that it's using the tools and it's getting information from only page 2, right? Good. So once we have that, now let's incorporate the summary tool to make sure the router is able to pick the right tool to use. So in the last video, we have seen how to use the router query engine. So we had two different tools. We have the summary tool and we have the vector query tool. So now let's create the summary tool again, and let's create the same scenario as we did last time, but now we are incorporating function calling capabilities into whatever we are doing. So we say from Llama-Index.co, I'm going to go ahead and import the summary index. So I'm also going to go ahead and say from Llama-Index.co.tools, I'm going to go ahead and import the query. I'm going to go ahead and import the query engine tool. And I'm going to create summary index. Is going to be because the summary index, we're going to pass in all those nodes. And I'm going to say summary underscore query summary query. Okay, this is going to be a quick query engine and not a query tool. So query engine is going to be equals to the query engine from defaults. And you're going to go ahead and pass in a couple of things. So this is actually wrong. So I'm going to say basically, let me just go ahead and say summary index dot as query engine. Okay, so once we have that there, we're going to go ahead and pass in the similarity search, things like that. You can pass in use async to just use asynchronous, which is much faster. So let me just make sure I'm actually calling the right function. So as a query engine, you're going to pass in, I don't need the rest summary, similarity. I'm going to use underscore async, use async, and this is going to be equals to true. Okay, You can also go ahead and pass in, we can also specify in the mode that you want to use here. So you can say response underscore mode, and the response mode, they're going to be saying this is going to be tree underscore summary. That's it. So that's all we need. And once I have this, I'm going to go ahead and create the summary tool. So I'm going to say summary. Okay, let me get that spelling right. So summary underscore tool is going to be equals to the query engine tool from defaults. And you're going to go ahead and pass in the thing. So I'm going to pass in the name. Okay, so let's just go ahead. The query engine is going to be the summary query engine. You're going to call this a summary tool. And you can give it a description if you want. So you can pass in description. And we covered all this in the last video. So we're going to say useful for summarization of let's say of the LoRa paper. Okay, good. So that's basically it. So once I have that, I'm going to go ahead and run this cell. So okay, so we have an error right here. It says okay, I need to forward a comma right there. So let's run this. Okay, we have an error. It says that unknown mode. So it's let's look at here. So we have the response mode, and it's equals to tree summarize. Okay, not tree summary, but tree summarize. My bad. So let's run that again. So hopefully that runs, and it did. So once we have that, now we can go ahead and actually ask it a bunch of questions. So we can create a response right here. You can ask it right in the summary tool, and then let's say we're also going to pass in the vector tool as well. So the vector underscore vector query tool. We can pass in the vector query tool as well. So we have, in this case, you have two tools now. You have the vector, the summarization tool, and the vector query tool. So now the LLM can ask the question, any question to the LLM, and let's see if it's able to pick the appropriate tool that you can use to address that. So let's copy this first, and we can go ahead and paste it in here, and let's see what which tool it uses to answer this question. So if you run that, and we can go ahead and actually print the response. So print the string version of response, and let's run that. So you can see this is a string version of the response. So it uses the vector summary tool, right? So let's ask it now to summarize for us a document. So let's not use the word summary. So tell me about the LoRa paper in a summary format. Okay, I use the word summary. Anyway, let's just test it out. So let's see which tool it calls. It calls the summarization tool, and it's going to pass in the LoRa paper, and let's see what output we get back, and then we can print out the response as well. Yeah, so that's basically how we can have multiple tools when they're different tools. So you can see this is a summary of the whole LoRa paper, and you can read about it if you want to. Yeah, so that's basically how we can use the different tools to do different things, right? So you can see how you can see how we can use the tool calling with an agentic RAG system. So good. So once we are done with that, so we can actually print the source document again if you want to. If you want to print the source document, you can go ahead and do that. Copy this and then print the source document of that summary. And the source document of this summary should be all the document that all the different nodes that we have, right? So you can see all of them, all that information right here. So it ends only page 26, right? No, page 1 actually. Yeah, so that's basically it. So once we have this done, that's basically how we can build your own tools and be able to pass these tools into an agentic RAG system. So we have seen how you can add simple Python functions. We have seen how you can convert your own data such as PDFs into tools that the LLM can use, and you have seen all that functionality. So in this case, it's just up to you and your creativity on what you want to do. So basically, you can create a tool that calls an API, takes in some parameters, calls an API, and then does something. That API does something that the results of that API that is returned. And you can do really complex stuff, or you can build a booking system whereby once the user specifies their booking information, that booking information is stored inside of a file, or you can connect to something like an SQL database and store all that information, right? So that's basically it for this video. In the next video, we're going to look at multi-step reasoning capabilities and how we can really leverage that to do really complicated things, chat with multiple documents, solve more complicated problems, ask it more complicated problems. And that's one of the main difference between the agentic RAG and the traditional RAG, that the agentic RAG can do more complex tasks, right? So with multiple step reasoning, chain of thoughts, we are able to achieve that using agentic AI. Okay guys, so that's all for this video, and I hope you found this video helpful. If you did, you can follow me on my different social medias. You can follow me on Medium, where I have an article of this video as well. You can follow me on YouTube, Code with Prince, where hopefully you're watching this video. You can follow me on X, and on LinkedIn you can follow me at Prince Cramper. If you want to build any projects, you have any ideas, you have any you need consultation on anything to building RAG systems, you can always reach out to me at Prince Cramper on Medium, and I'll be glad to help you to resolve whatever issue you have. So guys, thank you guys so much for watching, and see you in the next one. Don't forget to like, to share, to subscribe to the YouTube channel, and keep updated with the next video in the series. So thank you for watching. See you next time. Keep safe.